I know when we bought that Timco, we had decided we were just gonna run Schaefer's in it completely, engine, hydraulic, everything, and it's paid off. I mean, there was a crack on the main boom, you know, just from wear and tear and fatigue, and if the whole rest of the machine held together as good as the pumps did, we'd be in real good shape.
I mean, we used to change pumps on them quite regular. You know, one would go bad and then another one, and you've got to try and filter the whole system and get all that out of there. So we were as surprised probably as the guy that rebuilt them that they were in that good a shape.
It definitely has made a big difference. I think just oil change intervals, dropping the heat down on the hydraulics, and O-rings and hoses and pumps and just anything you can imagine. I mean, little old O-ring cost $1, you know, and you have 1,000 of them in a piece of machinery that you have to change every 1,500 hours because heat makes them hard and they start leaking oil. So
it's saving us money by maintenance costs. I mean, the wear reduction that we see in the components is tenfold of what you do with normal conventional oil.
Well, the hours that the machine has, I believe it currently exact hours are 9,343. Most Timcos, any kind of feller buncher, when they get to see that amount of hours, you're needing to go through the pumps and the travel motors and even the final drives. And we had some leaky seals, which none of the pumps or motors have been resealed in the 9,000 plus hours that this machine has had on it. And that's what made us decide to tear it down.
So these are the critical areas here and here. And then as well as this area is where this, what they call the slider block slides, that controls that movement of the swash plate. As this moves, that swash plate moves. And that looks very good. This is what they call a cup spring stack, and that's very critical to your, this always gets replaced. It doesn't make any difference. It's similar to a bearing. Always gets replaced, along with the seals. And you look at this now, slight, very slight cavitation. I'd reuse this without any problem whatsoever. So here again, no wear on the internal side of this. They can do this rebuild, but after this they're going to have to replace this shaft because there's a little bit of backlash there. There's the swash plate, and that looks beautiful. So now this critical area under here, where the roller bearings are starting to wear, but this one I can reuse this one. 9,000 hours is more than enough on a bearing. They always get replaced on a repair. Okay, this pump right now that we just took apart will get nothing but new bearings, new seals, and testing. This is a control piston. The majority of the time, you can see fine scratches. Okay, I can see one fine scratch, but typically this will be full of really fine scratches, and a lot of times there will be one side that will have a wear spot. So that right there is an indication that you just don't see that very often. Typically on this, and you can see there's a very, very, very minimal, super slight wear spot over here. And I've seen these where they've been oblong, and I've seen them where they've been just scratched up and that wear spot be just huge. This piston, which is a hardened metal, slides in and out of there. And typically what I'll find is, because this is such a softer material, it can be egg-shaped or be scratched or worn severely. I usually would replace this, don't need to. This is the control piston. This rides in here, and it's a metal-to-metal surface, whereas the other one was brass to metal. And what I would typically find when I take these apart, the scratches that I find would be going this way. And I can find one here, which is unbelievable. because this is from a pump that does basically the same thing as this, and it runs metal to metal, and that's what I will typically see out of this component, is scratching like that. Your key wear spots on the shafts are where these teeth engage that ball that I showed you on the other two pumps, and you see there's nothing. This is where the bearing rides, minimal wear. Looks exactly the way it's supposed to look. And the pistons look good, nothing, no wear whatsoever. Minimal scratches. So like I said, out of this whole thing, the only thing I would replace is the cup spring stack. The ball looks good. Another bearing, and it looks good. And as you can see, there's scratching, superficial scratching, cavitation, very minimal. The critical surfaces on the back, there is some wear here. Again, I will leave that up to the customer. Metal pump, steel pump, it's a gear pump. So the gears are metal and they ride against these wear plates. And that is a constant ride at whatever RPM they're running at. So these are steel, but they're coated on the face with brass and then again with Teflon. You can see minimal line right here. And we're talking about steel riding against that. And there is its opposing plate, another small line. So that wear pattern is very, very minimal. I called the customer because I didn't believe it. I said, are you sure this pump has been on this machine all this amount of time? And he assured me that it is the original pump off of the machine, 9,000 hours. I've taken a lot of these apart and I've never ever seen wear plates with that minimal wear when you have steel riding against a Teflon coated plate. I was more shocked than amazed. There's a little bit of wear here, very minimal. I'll reuse this. I will put that on the lapping table, lap that out. You won't even know that that's there. So here again, 9,000 hours.
And even after he got it back together and he reused every hard part in the pump, which he's never done before, he said it tested just like brand new. And all it had was seals in it. The flow test, the pressure test on the saw pump. The results of that, the pump performed as a brand new one would perform, as if all the hard parts were brand new, never been used. And they had 9,000 plus hours on them.
Traditionally, you have to reseal those pumps because of the high heat every 2,000 hours. So we have saved 4 teardowns with this machine that we didn't have to do that normally you do have to do. And we just put a figure on that, and it's about $10,000 to $12,000 in labor every time you have to tear one of these machines down to that extent to be able to reseal it. And so over the life of the machine, that's about $50,000 over, to the 9,000 hours where we are now with this machine. And so I just pulled the maintenance history up on it, and just the labor on that machine since we've had it is a little over $100,000. So that figure would have been $150,000 if we hadn't been running shapers. That's a concrete figure for us. That's one we like to use.